Hey everyone, welcome back to my video series on solving LeetCode problems. So now, I decided to do a medium this time. And let's see, remove duplicates from sorted array 2. Given an integer array num sorted in non-decreasing order, which is ascending, I guess, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array. More formally, if there are k elements after removing the duplicates, the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Okay. Return k after placing the final result. Okay. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. Okay, so the examples are 1, 1, 1, 2, 2, 3, and we need to remove this one. Okay. So what we can do is we can just, I'm going to create something here. Make directory, this is 80, right? 80, remove duplicate from sort array, code 80. So I think what we can do is, let's say we're going through this. Oh, 1, okay. Oh, another one, cool. Oh, this one's a bit too much. So let's just shift everything back one step. And then let's just continue party. So, come on, solution.py, remove duplicates, list, and solution of remove duplicates of 1, 1, 1, 2, 2, 2, 3, 3. I think that was it. 1, 1, 1, 2, 2, 3. I'll just do 2, 2, 2. Let's go. So the array is sorted, so it's ascending. We can check. We can actually have a counter. Same counter, and it's 0. So let's iterate for I index val and enumerate nums if index is bigger than 0, yeah, and val is equal to nums minus 1. So if it's the same, and if it's the same, then we do stuff. If not, same counter equals 0. That's one thing we do. So if the number is equal to the previous, then we do if same counter equals 0. Actually, is smaller. If same counter is smaller than 2, then same counter plus equals 1. It increments. Else, we need to remove it. So we need to shift everything that's forward back. So shift the rest back one step. And that is a bit of a pain to do. So now I need to go for new index in Oh, this is boring. So for new index in range from the index that we are on until length of nums, we can say that, not the index that we're on, the next one, we can say that new index, actually nums of new index minus 1 equals new nums of new index. Oh, and since we're modifying this, I think we shouldn't even do this. I think we should have val equals nums of index, and we should iterate over the range of length of nums. And why is that? Because it's not like healthy. You can have like a lot of problems if you're doing this, iterating over an array's values and changing the array itself. Here we're just iterating over the index, so there's no problem. So let's see if this works. I don't think we need to return anything. Do we need to return anything? Oh, we need to return 5. What is 5? Oh, okay, so the final number of digits. Okay, we'll get to that later. So let's see, it's 1, 1, 1, 2, 2, 2, 3, 3. So it should be 1, 1, 2, 2, 3, 3, and then the rest doesn't matter. 1, 1, 1, 2, 2, 2, 3, 3, 3. Didn't change a thing. So let's see. So the first value is 1. If index is bigger than 0 and val equals nums minus 1, okay, it's not the case. So same counter equals 0. Val is 1. What? Numbers of index minus 1. Let's see if everything works now. Just like magic. Nums. 1, 1, 1. Okay, still doesn't work. So let's see. So yeah, now we're going for the 1 again. So index is 1 and val is equal to the previous one. So same counter, smaller than 2. And I think it should be smaller or equal to 2. Still didn't change a thing. Let's go. So counter 0. Increase the counter. Now val is 1. It's more equal than 1. So nums still didn't change. Wow. Where did I go wrong? So val is 1. We're gonna add a counter, so val is 1 again. Yeah, the counter, and now val becomes 2. No, this doesn't make sense. Well, it does if I initialize it as 0. Oh, I think it's changing now. Okay. 1, 1, 2, 2, 3, 3, 3, 3. Okay, you did what I wanted. So I need to have like a shift counter. starts at 0, and whenever we do this, shift counter plus equals 1. And now we just return shift counter. And we do that, and we should have 1, 2, 3, 4, 5, 6. Yep, shift counter is 4. Why is it 4? It's 4 because it's not counting the first ones. And the first ones should always count with the shift counter. No, wait. I'm doing it wrong. 8. It shifts. How many times does it shift? It shifts once, twice, and that's it. So why do we have shift counter 4? Weird. So the first time it shifts, it's when the 2 comes here, right? 2 comes here. And the next time it shifts is when the 3 comes back. Oh, I get it. Because I'm putting a 3 in, because I'm leaving the 3 in the end. I'm leaving it there. So for just moving things back. I need to replace them with none. That would be interesting. If I put the shift counter here, like nums minus shift counter, and then for and I can always say that the next one must be a none. If new index plus 1 is smaller than the length of nums of new index plus 1 equals none. And then at this moment, actually, I don't even need to do this. I know the shift counter, so if index is bigger or equal than length of nums minus shift counter, break. And now the shift counter is 2. So it did 2 shifts. The values are the same, and I just need to return length of nums minus shift counter. Let's go. Oh, too good to be true. Okay, let's see where it failed. But it did a lot of things right, a lot of exercises passed. But that doesn't matter if they don't, all of them don't succeed. Okay, so let's come here. We have 1, 1, 1, 2, 3, and then we're moving the 2 back. The problem here is that I am increasing the index always, and I shouldn't. I should stay in the same index because things are moving back. So I think I should just go for whoops. While index is smaller, and shift counter, and I just go for index equals 0, and then I just need to increment the index at specific places. So index plus equals 1, and index plus equals 1. So at this moment I'm moving the 2 backwards. Yeah, so I have an extra 3 there. It's okay. Yeah. Length of nums 6 minus 1, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. See if it works. 1, 2, 3, 4, 5. It works. But the runtime was super bad. But the memory was super good. I think I can do some things to improve it. I think I can also move the index. Let's see. I'm doing index plus 1 here. I think I can just do index plus 1 at this moment. And same counter equals 1, maybe? I don't know. Well, I'm happy the way it is. See you guys later.